Welcome, my digital pathology trailblazers. How did you like the AI co-hosts? Let me know on LinkedIn or via email. And if you haven't heard the AI co-host, it's in the previous episode number 104, at the end of the episode. But today, Digital Pathology Place achieved an interesting milestone on YouTube. We have monetized our channel. What does that mean? That means that now when play ads on the Digital Pathology Place channel, then they will pay us money, which is going to be probably marginal. But nevertheless, it is something that happened because of you, because you, the Digital Pathology Trailblazer, are watching the YouTube videos. So thank you so much. And if you haven't checked the YouTube channel yet, please go ahead, check it out and subscribe, because then you can get even more value from the digital pathology information that I'm trying to spread out on the internet. So if you have not checked the Digital Pathology Place channel on YouTube yet, please do it and subscribe, because then you can get even more. As I was checking all the settings for the channel, I came across the very first video that I recorded on the channel. It's about artificial intelligence in pathology. And I looked at it. It was in 2019. It was a presentation I gave at a conference. Actually, my husband was invited to, present. But I thought, oh, would they not be interested? My husband is a clinical pathologist, and I'm trying to invite him to the podcast to share a little bit of his expertise. But I didn't manage to do that yet, so stay tuned. Anyway, so he went to this conference and he was asked to present on behalf of the company he was with. And I thought, oh, would they not be interested? It was a pathology conference in Hershey, Pennsylvania. And he asked the organizers, and they said, yes, sure. So when I was preparing the presentation, I was really practicing. I also recorded a YouTube video, and you can have a look at this YouTube video and see what the beginnings are when I look at my videos now and the confidence and the expertise I gained. I appreciate that there was a learning curve. Nevertheless, this content is still valuable, and I thought I'm going to share a glimpse from the past. Actually, this happened on a pretty special day because So I was recording this presentation. The sound is not great again. I was recording this presentation at the hallway of our apartment. My son was less than a year old then, so I had to leave the apartment, go to the hallway. I sat in front of a window and I was recording. When you go to YouTube, the sound is not fantastic. I, of course, cleaned it up for you here. So I recorded before the conference, put it on YouTube, and I am greeting all my 0 YouTube subscribers. Now we have over 3,000. And then I think a week later, I presented. I was pretty stressed. And that was on a very special day because it was the day I got engaged. After the presentation, we had our son there, and when my husband was presenting, I was taking care of the son. Then I was presenting, he was taking care of my son. And then we went for a hike. We changed from our fancy conference clothes, and we went for a hike. And I was all relaxed, all fun, all good. And then my husband starts taking out stuff. And I'm like, oh, that's so cool. We're having a picnic. I'm carrying my baby in the baby carrier, just hiking ahead, super happy that I can relax after this presentation that caused me a little bit of stress. And he takes out the blanket, and he takes out some food, and then he takes out flowers. And I'm like, you carry flowers in your backpack? And until the moment he actually kneeled on this blanket on the Appalachian Trail and asked me if I'm going to marry him, gave me the ring and asked me if I'm going to marry him. I had no clue that this is the day that I get engaged. So this video will always remind me of this very special day and how Digital Pathology Place began. So enjoy Dr. Alex from over 5 years ago, and let me know what you think.
Learn about the newest digital pathology trends in science and industry, meet the most interesting people in the niche, and gain insights relevant to your own projects. Here is where pathology meets computer science. You are listening to the Digital Pathology Podcast with your host, Dr. Alexandra Zhurov.
Hi, my name is Alexandra Zhurov. I'm a veterinary pathologist and I'm passionate about digital pathology. I had the chance to speak at the annual meeting of the Association of Clinical Scientists in Hershey, PA, and I wanted to share the presentation I held there with all my YouTube subscribers, which is currently no subscribers, 0 people, because that's my first video, but with my future subscribers. Let me tell you about artificial intelligence in pathology practice and how advanced we really are. We know that there is a shortage of pathologists in the world, and AI would possibly save time of pathologists and they would be able to help more patients. So where do we start? I'm going to introduce you to the subject. We're going to talk about pathology informatics terminology. What is the current status of AI in pathology? What are challenges in biomedical image analysis? What is the chameleon challenge? What's a challenge design? Chameleon challenge is the most famous one in pathology. What tools are available and which are not? And what are the hurdles for AI applications in digital pathology? So let me start with some introduction. We are bombarded with artificial intelligence and digitalization of pathology on pathology conferences. The accuracy of the AI models often comes very close and sometimes exceeds inter- and intra-pathologist variability. And terms such as machine learning, deep learning, neural networks, they increasingly are being used in pathology contexts. So the question is, are we approaching a new era where AI will dominate pathology, or is it still a long way off? Let me start with the terminology to understand it better. What is artificial intelligence? It is a branch of computer science about systems which can learn from data. So we encounter AI every time we touch any of our mobile devices. And examples here would be Google predictive searches. When we start typing something in to look it up in Google, we get a suggestion, and usually these suggestions are correct. And this is an AI product recommendations on Amazon. This is also artificial intelligence. When we buy something and we get suggestions of similar products, or for example, we get this message, customers who bought this also bought that, and it suggests us different products. Music recommendations by Spotify based on the songs that we already liked, and Google Maps fastest route. That is based on the current available traffic information when we are using it as a navigation system already. And based on the current traffic information, Google suggests a faster route. What is machine learning? This is a branch of AI that is based on the idea that computers can learn from data as humans learn from experience, and then they can make decisions about data without human interactions. We have 3 types of machine learning: supervised learning based on labeled data, unsupervised learning based on grouping unlabeled data points with similar features together, and reinforcement learning, where the user of the algorithm or the model gives the model feedback on what was labeled incorrectly. What is random forest? Random forest is one of the most popular supervised machine learning algorithms. It's a forest of decision trees. These do not tend to perform so fantastic in pathology. What is deep learning? This is a subfield of machine learning in which the models resemble neural networks of the human brain. Those models within deep learning are called artificial neural networks. And an example or type of artificial neural networks are convolutional neural networks, and these have dominated the deep learning space. Computer vision is a field of computer science trying to mimic human vision, and patching is dividing large pathology images into small patches. And to better picture this, we need to know how big such an image is. And so a whole slide image is 15 gigabytes, more or less. What is 15 gigabytes? It's three-hour-long high-end quality Netflix movies. Just one slide, one digitalized pathology slide. They need to be divided in smaller squares, and these squares are called patches, and the process is called patching. Graphical processing units are necessary for quick processing of pathology images. These are chips on the computer's graphic cards designed to rapidly process graphics. They're used in gaming, video gaming computers, and are indispensable for fast processing of whole slide images. Computer-aided diagnosis is when clinicians use computer-defined regions to assist them in making the diagnosis. This is already in routine use in radiology for the detection of breast cancer foci in mammograms, and a potential use in pathology would be pre-screening of lymph node sections in cancer metastasis. This is a tedious task, takes a lot of time. There are many sections of the lymph nodes, and pathologists have to screen them under the microscope. It would significantly save time if they could have them suggested by the computer and then just say yes, no. What is data augmentation? This is a way of getting more data when we don't have enough data. And on this example, on the left side of the screen, we have 4 mitotic figures. They have been slightly altered, shifted a little bit, and we get from those 4 mitotic figures, we get 16 mitotic figures. We increased our data set from 4 points to 16 data points. And these are seen as by the computer as separate data points. So we don't have enough data. We can augment them to have more for the training of the system. What are probability heat maps? This is a color-coded way of visualizing the classification results of the deep learning model. And on one end of the scale is corresponding to a high 100% probability of a feature, in this case of the tissue being a tumor, and the other end of the scale, the blue one in this case, is corresponding to 0 probability. So we can appreciate that those all red regions is probably tumor, and the regions in between, and there is lower probability of tumor. To visualize how those terms relate to each other, the broadest term is artificial intelligence, and the machine learning is a part of artificial intelligence, where we have the patching, random forest, and deep learning is part of machine learning. We have artificial neural networks, convolutional neural networks as an example of them. We have probability heat maps and data augmentation. Computer vision is the discipline that uses all those models. GPUs, graphical processing units, enable us to process a whole slide images fast. And in the end, the algorithm can help us with making the diagnosis, and we have computer-aided diagnosis. On conferences and in publications on LinkedIn as well, we are surrounded with all the AI news. But what is the current status of artificial intelligence in pathology? As of today, May 18, 2019, there is no FDA-approved AI solution for pathology on the market. There are initiatives supporting and accelerating the development of AI applications, like the FDA Digital Health Innovation Action Plan, Digital Health Software Pre-Certification Program, Pre-Cert, and in different disciplines, AI already made it officially with an FDA clearance or approval, like in diabetes research, in cardiovascular and brain disease treatment, in radiology, but not in pathology yet. And in pathology publications about AI, all those publications come from R&D departments, either academia or industry, different companies, but it's research. So to foster AI and to encourage people to develop AI solutions, and challenges in biomedical image analysis have been established. And what are these? These are competitions aiming to compare new and existing algorithms in biomedical image analysis. And researchers are very strongly encouraged to take part in those challenges in order to promote and contribute to AI development. The participants try to solve a stated problem on a common data set, and they can use a solution of choice and are required to publish their results. So the most famous challenge in pathology was Chameleon Challenge, organized in 2016 and 2017. And this and other challenges are gathered on the COMIC platform, standing for Consortium of Open Medical Image Computing. And they are called Grand Challenges. They are the most famous in biomedical image analysis. But there are also other platforms that are hosting them. And these include CodaLab, Kovalik, or Virtual Skeletal. And let me tell you about the Chameleon Challenge, what it was about. It, as I said, was one of the most famous challenges in pathology, maybe not in biomedical image analysis. There are different ones that I'm not aware of, but in pathology, this one was the most famous one. It was hosted in the Netherlands by the Diagnostic Image Analysis Group and Department of Pathology of the Radboud University Medical Center in Nijmegen. And as I said, there were two editions, Chameleon 16 and Chameleon in 2016 and 2017. And almost 100 submissions for both of these challenges were done, both from academia and from companies. And the problem here was detection of breast cancer metastasis in whole slide images of lymph nodes. The participants were working with the same training and test set of 1,399 hematoxylin and eosin stained lymph node sections. And they were free to use any image analysis method to best solve this problem. So they didn't have to use deep learning, but it just so happened that the winners used deep learning. So this performed the best. This is how the challenge is designed, not only the pathology ones, but the other ones as well. A meaningful task need to be defined. In this case, that was breast cancer metastasis detection in lymph nodes. Representative data needs to be gathered. In this case, it was labeled whole slide images. A reference standard needs to be defined. That was the diagnosis of the pathologist and their annotation. And the discriminative evaluation metric needs to be determined. And in this case, the consensus of the algorithms with the pathologist's input was measured by Cohen's kappa. And the participants are required to write a peer-reviewed paper. So what are the tools that are available and what are not available? There's no FDA-approved AI solutions for pathology, like I said, but why is there not? We will see later. But for research use only, image analysis software companies are starting to incorporate AI modules in their solutions, where a pathologist or a user can annotate target structures to train the model, and later the model detects those structures automatically. For example, the pathologist or the user annotates glomeruli on one slide or on one part of the slide, and then the algorithm detects the rest of the glomeruli on the other part of the slide or on the rest of the slides. These solutions are currently available from different companies like Indica Labs, Visiopharm, and Aphoria. And these tools incorporate random forest or deep learning modules for image analysis, but as I said, they're for researchers only, nothing for clinical use so far. And why not? Why is there something AI-based in other disciplines and not in pathology yet? So there are some hurdles that are pathology-specific. And these include lack of validated tools, as we already said, lack of labeled data. We said that the supervised machine learning needs a large amount of labeled data. This would mean that the pathologist, instead of looking at slides, would have to go and start annotating whatever structures they want to have detected. And it's not going to happen because they are supposed to diagnose patients and they use slides for that. The non-digital, so lack of labeled data, high complexity of histological images in comparison to radiology or cardiology. The complexity of histological images is much, much higher. We have different colors, textures, tissues, organs, and this multiplied by each other contributes to this high complexity of histological images. The dimensionality of pathology diagnostic problems is also high. And the example that we had, the detection of neoplastic foci in lymph node section, is just one binary problem that was used for the competition. But the dimensionality of the primary diagnosis in pathology is a lot higher. There is a different pattern recognition involved and incorporation of many different processes visible on the slide and different data available about the patient. Another problem or hurdle is that pathologists are the gold standard, or they are generating the ground truth. So the algorithm can only be as good as a pathologist. And also pathologists tend to differ. The algorithm is going to be close to what one pathologist says. Does it mean that it's a good one if another pathologist says something else? So that's a hurdle. And the affordability of computational power and storage space is a problem. Those GPUs that are required for processing these huge slides cost a lot more than a normal PC, a normal computer. That's a hurdle. And we need to store somewhere those digital slides, enormous amounts of data. So that's another. To sum up, AI is affecting our lives every time we touch a mobile device, phone, whatever, computer. It has officially entered various medical fields, but in pathology, it still remains restricted to research use only. There are many pathology-specific hurdles to overcome, and the most important being enormous size of pathology images and complexity of morphological patterns. The regulatory pathways have been already paved by other disciplines, which is good. And the FDA officially supports the Digital Health Initiative with their Digital Health Innovation Action Plan and Digital Health Software Pre-Certification Program. To answer the question that we asked at the beginning, is it going to happen? Yes, it's going to happen soon. AI is coming soon. We're not quite there yet, but it's coming soon. So pathologists should prepare. They can prepare by going digital in their labs, by recognizing where AI will add value. So it may not add value to every step of the pathology workflow. It's crucial to recognize where it would and apply it there. And they can prepare by educating themselves. There are courses available. One course, for example, from Digital Pathology Association, an online course that the pathologists can take. And they should proactively engage with any initiatives and be it the challenges, like the Chameleon Challenge, or cooperations with academic partners, with industry, with different companies. Thank you very much for listening to me, and I hope you liked it. If you liked it, please click subscribe to my channel. And if you have any questions, don't hesitate to write an email and go and check out my blog, digitalpathologyconsulting.com, where there's an article about this presentation as well. And I will also put this presentation for download if you would like the slides. Thank you. Bye. Here are the references in case you want to go back to the primary literature or follow the links for things that I mentioned.
Thank you so much for listening to the end. That tells me you are a real digital pathology trailblazer. This video was posted 5 years ago and it has 3,000 views on YouTube. This is one of the most viewed videos. Of course, it has been there for the longest. And there is a whole chunk of what happened in the last 5 years missing, like all the generative AI, foundation models, ChatGPT, and all that good stuff. So, of course, there is an update video that I posted 5 months ago, and this has almost 2,000 views already. So I'm going to link to both the older version and the new version if you feel like comparing how I was presenting then versus how I'm presenting now. In those over 5 years, my YouTube channel is telling me that there are 510 videos. It's a little bit elevated because at some point I connected the Digital Pathology podcast. So all the audio podcasts are on YouTube as well. When Google decided to merge Google Podcasts with YouTube, we migrated to YouTube. So it doubled the number of videos, but definitely over 370 native YouTube videos. So I decided to create a structured curriculum out of those videos. They were being created more or less on demand when I was hearing from you, oh, I would like to have a video on that. I would like to have a presentation. Or if I would give a presentation, there was an option to record you're going to find things like that as well. Recently, I started adding conference vlogs to give you a glimpse of what's happening at the conferences and the live commentary on what's happening. So I decided to create a structured curriculum and create course based on selected and curated YouTube videos. I'm still working on putting it together, but if you're interested in checking it out in exchange for feedback and testimonials, I have a waiting list for 100 digital pathology trailblazers who will get access to this course for free. So if you're interested in test driving the course, giving me your feedback, whatever you think about it, you just let me know. And if you love it, if you would give me a testimonial, then this course is going to be for you for free. I already shared it with the digital pathology trailblazers from my mailing list, and several of them signed up. There's still a few spots left for you, the podcast listener. But before the free access waiting list gets shared on social media, I decided to share it on the podcast. So for you who listens to the end, this is an opportunity to get access to this course for free. And let me know what you think. Check out the link in the show notes, YouTube course waiting list, sign up, and whenever I have it ready, it's going to end up in your inbox. And I talk to you in the next episode.